So what is normalization? Can anyone tell me? No worries. So generally, what is normalization is that how do you segregate different columns in a normal definition. I'm not talking about how do you segregate columns in different tables. That process is called normalization. Now, why normalization is necessary? Why do we have to segregate the databases in different tables or different columns? Anyone wants to try? Any idea?
To organize the data.
Sorry, Abdul.
Organizing
Exactly.
the form.
Organizing in a proper way. That is first thing. Second thing, someone in chat said faster inserts. Yes. So I would say insert operation. That's correct. Third thing, to reduce space. You may feel like why we are reducing space. We'll take an example and we'll see that. And also when we are doing all these things, okay, furthermore things also we can achieve: simplicity, maintenance, all that stuff, readability, understandability, all that things. So maintenance is also other part. So that we will see when one of the example that we take. Generally, normalization, if we understand from the theoretical perspective, you won't understand much key why normalization is necessary. And in tradition, in the sense in companies also, generally we do not talk in terms of normalization, right? Like when you are preparing document, your low level design document, your high level design document, whatever you are proposing some feature, key I'll develop this feature like this. Okay, so you have to create some documentation, and documentation first should get approved by leads and managers and all, or architects. Sometimes architect prepare such kind of documents and they give it to you, and you have to follow the same kind of design, right? So in that, generally we do not talk in terms of normalization, but the design that we do is generally in normalized form, generally, right? And then on further discussion, you may think that more normalizations are necessary, then you put it, but we do not define or put a definition that, hey, this database design is in some normal form. So normalization has been defined in multiple normal forms, something like 1NF, one normalization form, 2NF. Okay, then what is that? 3NF and Bcnf. Then there are 5, 6, and 7 are there, but it's useless. I'll tell you why. Okay, Bcnf is voice code normalization, so founder of those folks, and that normal form it is considered. We'll understand what is first NF, what is second NF, what is 3NF, what is Bcnf from example. A small example, we were seeing example of student, right? Student database and all. So from the same student database, we'll start understanding the normalization forms, and then we'll see that in industry generally how do we have to start thinking and create a design. Okay, so far clear? Okay, so we'll start. So generally, a simple table with all data, all necessary data in a single table is called 1NF. It is in 1NF form. Okay. So the atomicity is one table. Atomicity is table 1. So if I give an example, the example is simple. You are putting roll number, student name. Okay, what is the student's class? Let's say IT, CSE, EC, all that things. Okay, and what is his, let's say, age? and what is his address. If you are putting all these values in a same table, then the atomicity for this table is 1. That means everything you are finding in the single table. So atomicity is 1, and all the data you are putting up in single table. That's called single normalization. Right? Now, what will be the primary key over here? The primary key, you can put roll number, right? The primary key you can put as roll number, or you can add an ID column. So generally ID columns are added in SQL tables. So combination of ID and roll number can be used as primary key, correct? So in that way, uniquely you can identify which student is at, or which student record is at where in the table. So far clear? Nothing specific, nothing what you can say complex. Now in a simplest,
And can we have same ID?
yeah, you can put it. You can put it, but generally what happens is, if you put the same thing as an ID, it's a data redundancy, extra storage, right? Unnecessary. Instead of that, generally roll number, generally what people follows is, let's say the year of, let's say a year of enrollment 21, the class name IT, and roll number 01. Then 22 student, 22 year student, 22 in the sense the enrollment of a student is 22. So batch of 22 to 26, something like that. So such kind of some format you will follow to create roll number for uniquely identification, right? So that's why generally we do not put roll number and ID same. This is simple. Otherwise, what will happen? The same kind of data you are storing again and again. Okay. Now, when you are segregating data into multiple tables, okay, that is called 2NF form. But in 2NF form, what you are doing, that both the tables having single NF form structure, and they are storing only simple dependencies, something like, let's say, where it is, roll number to uniquely identify student, and student name, let's say you are putting, and the second table you are creating something like roll number and address. That's it. So when such kind of tables you are creating, two tables, one is just a name and second is just an address, something like this, two tables you are creating, such kind of structure is called in 2NF form. Now, along with that, you can put further tables as well. Clear?
So one column must be common. In both the tables, roll number is common.
Yes. Why is it so?
Yeah.
So to find it out, what is the unique identification, right? So something like, if we do not understand, if we understand it more clearly, actually not like this, 2NF shouldn't be like this. 2NF will be just dependencies to be in a segregated format. So something like this, let's say roll number and student name, let's say, and second table will be student name and address. So there is no single column. Actually, let's say student name you are putting as same. So not a primary key from here, roll number, from which you are defining the tables in a different format, but some other key or some other column from which you are segregating. Now with that also, you should be able to identify unique student. Over here, with a name, probably you may not identify unique student. So instead of that, you can consider it like combination of a first name, last name, and middle name. Probably that would be unique. Not sure. Let's say if it is also not there, then 2NF form, if we want to understand, then we can understand something like this: ID, roll number, and roll number and name. Let's say student name. Now, in such a way, if you are segregating tables, or let's say student name and rest of them, so the key from which you are bifurcating, it should not be primary key in one, but can be primary key in other. And in that way, when you are segregating, that is 2NF form. Now here, still the redundancy is there, that this is unnecessary information that you are storing. We can still bifurcate the data in such a way that such kind of partial dependency or direct dependency doesn't stay, right? So such kind of dependency is called 3NF form. So something like this.
Why are you splitting that space? Is it reducing the space?
Directly, it will not reduce the space, but when we take an example, I'll show you that how it is reducing the space. Okay. Because to understand how it is reducing the space and all, it takes a longer concept. Yeah, you can consider that whenever a single cell contains one value, but that is like what we can say by definition, that all the what you can say tables in a different what you can say structure. So something like key and name, you want to put it in a segregate, then it's called normal 1NF, is it?
No, like there is a mobile number column and it has multiple mobile numbers for single user. So that is not one. If there are two mobile numbers, it should be stored in two rows. I have this.
Sorry, I didn't get you. So actually in single normal form, it will be something like this only, right? Let's say for example, okay, if I take an example, let's say roll number 1, student name is ABC, and the class he belongs to is IT, let's say, okay, and his let's say age is 22 and address is something. Okay, now the same student has taken physics also as class. Okay, so he's also enrolled in physics and his age is also 22 and this. So now if I'm storing this, roll number is this one and ID will be segregated like 1 and 2. Now if you store data in this format, this is 1NF.
Yeah.
Like in previous definition also it was the same one, right?
Yeah, but here it means I was just reading on and it was saying that we have means it is with respect to storing multiple values instead of table segregation.
Acha, got it. So I think, yeah, now you understood, right? This way of formatting is 1NF. Right. Now, based upon like now if you understand this, if you define 2NF, then what it should be? Now it should be in 2NF in which way?
One column can contain ID and roll number and so here like we have to take we can make a relation between two.
Exactly.
And ID, roll number, and the second column will also contain ID. A roll number will not be there. ID and name, ID name and other rest of.
Exactly. So in that way, if you are segregating, then it is 2NF. In a different way also you can segregate. Previously we were using student name as something segregator, right? So in that way also you can do that. So that is 2NF form. That's perfect, right?
Yeah.
Now let's say in 3NF, if you want to understand how it would be.
Sir, can you explain this to us? I didn't get.
So
How are you deciding column names?
so deciding column names are not like on which one you have to. So what should be the deciding factor between dividing into multiple tables is that you have to split it in two parts such that some column in the sense, let's say the primary key is roll number or ID, right? Out of that one, you are keeping segregated in both tables, and rest of the data you are putting such that or segregating such that all your tables are in 1NF and there is no, I would say, common column in between this such that except ID, primary key or something, except those, such that there is a dependency on one to another one. So something like this, which the person said, let's say we are keeping some ID will be by default. So some ID, roll number and name, if we keep it in one table as in a name table, and other table if we create something like other information. Now in that, I'll again store what? ID, name, okay, and sorry, not name, ID, then the person's class and age and rest of the things, or roll number, ID, roll number, and rest of the detail. So in that way, when you are segregating, that is in 2NF form.
There should be one column, like primary key should be common in both the tables. Rest of one.
It's not necessary that primary key should be column. There should be some identification from where you can identify which roll number or which unique row is there.
Okay.
Correct. So you are just segregating name related information in separate one and rest of the information in separate one. Something like, if I take very simple example, let's say, okay, in a very let's take some other example. Okay, let's say we were taking about order management system, right? Let's just an example of order management system. We are also taking that one. So let's say you have some customer ID, you have some order ID. What is the order ID? And let's say what is the delivery location? Location is pin code. So let's say customer ID is 1, order ID is let's say 2, and delivery location is let's say 560037. So such kind of table you have stored. So let's say just a simple example. Now, if we consider this in 1NF, then what is 2NF out of it? In a simplistic way, I can do two tables, something like this: customer ID and order ID. Okay. Another table, order ID and location. Meaningful information from which I can find it out that for which order ID, what is the location. The same way previously, for which roll number, what is the name, for which roll number, what is the address. Got it? In the same way over here, for which customer ID, what is the orders that he have done, and for which order IDs, what are the locations. So generally over here, primary keys segregated, we can keep. Sometimes primary key same also we can keep. But the meaningful information you are storing into two different tables in a simplistic way, such that a dependency is there, but a single dependency is there, and directly you can find it out. Now let's say if I want to find it out, the same kind of table, that for which customer, what were the order IDs and what are the locations, I can find it out by joining or doing some other operations, right? Multiple inner queries or something.
So the way you created this two table, 2NF form. So by considering this two table, here order ID will be the primary key, right?
So in this table, customer ID is the primary key. In this table, order ID is primary key.
Okay, so we can reference
Yes.
the location from, so it's not necessary to put primary key in all the table.
Yes, it's not necessary.
Okay, so we can reference with other parameters also.
Yes.
Okay, okay. I thought like primary keys should be available in all the tables.
No. May not
Okay.
necessary. May not be necessary.
Okay, okay.
Now let's say, again, let's say if we come back to simple other question, let's say we have the same student table and we want to understand into 3NF form. Like previous example, we have just 2 columns, that's right. Then in 3NF, what it will be as a dependency. So generally in 3NF form, we understand that there is no duplicated data. So that means we understand, or we try to store that no duplicate record we store. We try to do that unless we have to do it by primary key, because when we are joining on something, we have to join in with the help of primary keys only. Okay. So something like, let's say we have the same kind of format. Let's say we have student roll number, student name in a single format. Let's say we are storing all the data. Okay. And let's say he is in which class in the sense IT and all that things. Now I'm storing furthermore, let's say what is his subject he has chosen. Okay. And what are his marks and what is his address. Now this is my normal table. Then what should be my 3NF should look like? So my 3NF should look like something like, let's say my student ID, my roll number, that should be defining for name and address. Let's say I'm creating one other table, something like name and address. Okay. And other related information like roll number and his marks and subject, for which subject, which one, in a different one. Third NF or third table that I'm creating is between class and subject. Probably all the people from IT, they are taking this 5 classes. The courses for let's say first semester is same. Everyone will take physics, maths, C++ or C++, and let's say something like MATLAB, just an example. Okay. And some common subject of let's say mechanics or mechanical drawing, something like that. Right. So IT's first semester students are taking all these subjects. So let's understand the semester ID as well. Okay. So all the class students of all the semester will take some subjects only. So I can put this segregated information also outside so that there is no duplication. Now here, Abdul, your question's answer is there. We know that for class, we have totally how many classes? Let's say total, let's say in some engineering college, 7 branches are there. Okay. And at a go, only 3 semesters are working. First semester, let's say third semester, fifth semester, and seventh semester. So 4 semester in a maximum, right? Second semester, fourth semester, sixth semester, and eighth semester won't be there because like that only it goes, right? And the subject they choose for each class, for each semester, they are defined. Let's say out of maximum 10, you can choose. What is the total number of combination that you can have it over here is 7 multiplied by 4 multiplied by 10, right? 280. While you have, let's say 10,000 students, 10,000 students database. Now this information, which is redundant, multiple times we are storing that one student has taken IT class and he has taken physics as a subject in a first semester, and his marks are this, right? So this information we are storing. Now the same information will be there for roll number 2 as well. The IT class, physics, and semester ID is 1 and his marks are something like that. So this information we are storing redundantly for all 10,000. So consider that 3 tuples are there, right? So 10,000 multiplied by 3, so 30,000 tuples we are storing, which we can store in 280 form, right? 280 form. Now you may ask, then how do we find it out that for the one roll number, what is the marks, right? For one roll number, what are the marks? Then for that we can have such kind of information that, let's say I'm storing like this: IT, physics, semester ID 1, and this information I'm storing into one of the what you can say, a table, let's say semester class table or semester subject table, and its ID is, let's say, 1, 2, 3. Then one information marks will be something like this: roll number, then semester ID or semester class ID, and marks. So here I'll store roll number, let's say 1, semester class ID 123, and his mark is 33. Roll number 2, same 123's class he has taken, IT first semester physics, and his marks are 48. So with this kind of a table information, I can still get all the data. Got it? So in that way, we are reducing the space. We are storing it in a normalization way. That means we are dividing the tables in meaningful information such that there is dependency between each other, so that we can find out the meaningful information. Correct? So in that way, we have to find it out. Got it? Now, what is about the next one and the last to understand is Bcnf, Boy's Code Normalization.
One question here. So suppose we created some table and we found sometimes some duplicate values, like two values are coming. So such type of situation occur, or like
so generally, such type of situation will occur in your normal what you can say, company scenario, because at that time, you know, too much of normalization is not expected. I'll tell you why. Okay. Before that, okay, let's understand that part first. Okay. Say for example, you are storing in so many format something like this: roll number and name. Okay. Another table is roll number and address. Another table is roll number and class, subject, semester ID. Okay, which we were discussing, right? So that we can reduce the space. And let's say for this, let's say we have some ID, and then we are storing something like this: roll number, class, subject ID, this table's ID, and his marks. Okay, so too much normalization we are doing such that the dependency injection is between roll number to this. Now it has come. Okay.
Yeah.
Also, roll number, CS ID, and what is his professor's name. Okay, who took this class, so that again we have less data to store, right? Just like previously, we have reduced from 30,000 to 280 tuples, right? The same way over here, we are still dependent, we are still reducing the dependency from this. Now, in such kind of way, if we normalize too much beyond Bcnf, so Bcnf is just not, furthermore from 3NF, some tables where the dependency still can be broken down, that we are dividing. Okay, so that is just a Bcnf, nothing more. But I'm giving the answer of your question. When you are doing this much normalization, what do you think when you need some meaningful information, something like, give me top 10 of this year? give me top 10 students of this year of IT class. How do you create the query out of it? First of all, for this year's IT class, you need to query this table. Where it is? So class subclass ID, we have created another segregated table, right? So that table you have to call, right? Then you have to find it out which roll numbers are associated in this class semester and semester ID and all that things, right? From that you find it out all the roll numbers. Then from that all the roll numbers you find it out what is their marks, because these IDs are there. So from that, let's say you find it out what are their marks for those roll numbers only, for those roll number class semester ID for this table ID only, which are for IT class only, right? And out of that you are finding the top 10. So you are doing joins between three tables, one table, another this table. So why I'm doing this as in a table? Because this is also a segregated table that we have stored without roll number, right? I have not drawn it over here. So three tables you are joining with. What will be the performance of your query when you are joining with three tables or more than three tables?
Yeah, it's very slow.
Exactly. Now, instead of that, even if, so there is always, like, normally if you are studying DSA, okay, the same phenomena we will use, and the same line I always say, okay, that's why I'm just repeating. So if you know, in Ayurveda, there is one famous saying, okay, in Ayurveda, and that reference I'm taking it up over here, and how we'll explain. What Ayurveda says that everything is elixir and everything, same things are poison. How? If you take in right quantity, that is elixir. If you take it up in too much quantity or too less quantity, that is poison.
Yep.
You like mango, if you take in right portion, it's fine. If you take too much more, you may get acidity, or if you take too much less, probably some of the things that you are getting from let's say mango only, probably some vitamins or something that you will not get it. Just an example. Okay, so the same thing I'll be applying over here. Same thing in the sense, too much of normalization will cause some problem over here, and too less of normalization will also cause problem over here. The right amount you have to define, and the right amount is not just key what is your query optimization. The right amount is you have to decide that what is the right amount of normalization, what is the right amount of wastage you will get it over here. Because when you do some less normalization, let's say in 30NF is the normalization, or Bcnf is the normalization that you have decided, still some wastage will be there of space. How much wastage is okay for you?
Okay.
Right, all that thing you have defined, and you have to create a balance and then define your database schema. I'll tell you why. In past, we have lots of restriction on space in computer when we are purchasing the space of CPU, database, and all that things. Now there are so many players in the market, and the technology is so advanced that, let's say, regarding cloud platform, AWS is giving you instances, also databases. MySQL is giving you databases. MongoDB is giving you databases. Microsoft is giving. Google is giving. Many companies are there which are giving, right? SQL.The, all of those are giving, right? The servers and all the things. The price are relatively cheap. So probably if you increase the wastage of space such that your query performance is much more higher than more normalization, then it's fine, right? You save 2 GB of space, let's say you save 2 GB of space, but instead of that, your 10,000 orders, let's say 10,000 daily requests you are getting, out of the 10,000, one query probably was taking, before normalization, 1 second. Just an example. Okay, after saving 2 GB space, your query is taking 0.8 second, right? Which one will you choose?
Of course,
There is So over here, there is marginal difference,
Yeah.
right? And over here, there is also a marginal difference. So
Okay.
anything is fine. Now you need to think furthermore. What if my 10,000 orders are increasing too much? If I further from 2 GB to let's say 10 GB space you are utilizing, and your query performance is increasing. Why? Because the normalization increased. So from 1 second, it became 1.3 second. What will you choose? Because whenever the space, more utilization, more space and redundant data, you'll stop creating, more normalization you'll do, the more joins you will have to do. When more joins will happen, the time of the query performance will increase, right? In a simple, so it's a linear equation. So what you'll choose? Now, if you see on an average, 30% of your API time increased.
Yep.
Right. So in a whole architecture, your queue time, because every order will come in a queue, it's a processing time, it's payment time, everything increased by 30 to 40%, because other systems will also have their lag. So instead of 30%, they will also increase by some, and let's say probably 40%. So consider that previously your one order end to end was getting completed in, let's say, 5 seconds. Now it is taking 8 seconds. People will get frustrated that, hey, rather than this, I'll buy from Flipkart, where seamlessly with 2 click only I can buy. Right. So when you're designing, you have to think in a very holistic way that which one will be best in terms of performance.
Oh, yeah.
Rather than rest of the thing. So that's why everything, either a space utilization, time utilization, everything should be in ideal state. Some wastage is fine, but your time utilization should be, you should try to least. Time utilization, you should not try to reduce that much. Let's say from 1 second to 0.7 second you are doing, but the space utilization you're increasing to 100 GB, and 100 GB is wastage space. So this is also not acceptable, because if you are doing this, right, from 5 seconds to person's time, you are reducing to 3 seconds. But person is, so far people were fine with 5 second and 3 second orders, but you are wasting space of 100 GB, which will increase you some cost, right? So that is also not fine, right? So if you store in 2NF form or 1NF form in everything, probably you will do this, but you will achieve this. That is also not good. So a right fine tuning is necessary. Clear?
Yes.
Yeah, someone has a question. Time complexity. Yes. What is time complexity came here?
How to calculate this time and space utilization?
So that is still further time and space utilization in terms of data structure, that we will take it up over here. And also in database, how to do that, we will take it up into when we are taking design. So generally in a simplistic way, if I take, when you're designing a table, you should consider something like this. Let's say roll number you are taking as in a varchar. So varchar, let's say 10 bits you have stored, 10 bytes. Okay. And address you have stored it for, let's say, varchar 100. Then what is the space it will take? What is the space it will take? What is the maximum number of records that you see in this table in, let's say, next 1 year or 5 years down the line or 2 years down the line? So that calculation you have to do. How many number of rows? Let's say 10,000 number of rows. And what is the space? Let's say, just an example, let's say 1 bit, a 1 byte. So that means 10,000 bytes you are storing. Correct. In that way, you need to consider or calculate that this much maximum table space you will need it. Generally, nowadays, we do not see much issues. Why? Because the table sizes are in terabytes and there is no dearth of space. People are storing the database in terabytes, and then gradually they archive as well. But even if the table size is in terabytes, huge data like in millions, then also it's fine. You might have seen, if you are reading some blogs, regularly, you might have seen so few days back Git stopped working. You remember why? Have anyone read this article? No? Okay. So in Git, they were using MySQL table for some branching related stuff or something, and the index column, ID column, has some size, let's say 8-bit or 8 byte, something like that. Okay, so just consider that how many values it can store with 8-bit. All those got filled. All those got filled, and they had to increase their ID size, or they have to think about something to do that. So consider that what would be the size of the table, probably in 100 to 300 GB or more than that, and still their indexing and everything was working fine. So I'm talking in that sense, key when you are seeing that kind of data, and still your query optimization is still best at the best. You might have used Git, you don't find issue whenever you are checking it out. You are creating some new indexes and so many things, anything that you are creating, right? New branches, creating new PRs, nothing, it's seamless within a fraction of a second. Even if their table size is this much, that all the IDs, possible IDs have existed. Say for example, when I say with one mobile number, 10-digit mobile number, how many mobile numbers can be created? Probability, sorry, permutation and combination. With 10 digits, how many mobile numbers can be created? First number can take 1 to 10. Second, third, and up to 10, they can take from 0 to 9. Sorry, 1 to 9 and 0 to 9. So all the multiplication. 9 into 9 into 9 into 9 into 9 up to 10 times multiplication of that much numbers can be created. So in that way, if you just consider that, what is the longest number of data that you can store in ID, for if the varchar, let's say, or integer 8-bit is also there, then also it's a huge data, 2 raised to 8. And if the bits are more, it can be still further more. Anyways, so the point is that even with large data, you can optimize your query and all that things. You have to design your SQL in a such a way your query optimization is at best. Your query output is at best.
So
Even if you're wasting some space, designing in the sense when you're deciding which tables to create, just like we were deciding which tables to create, right? Like in previous slides, we were deciding that if I create up to this much, and I have frequently such kind of queries, like give me top 10 students of IT class, give me top 100 students of IT class, give me top 10 of last year. Such kind of queries, if you have more, then your table design is wrong. We have seen such example, right? So that is called designing.
And also we have to like find out whether to use 1NF, 2NF, 3NF.
Not exactly. Not exactly. You have to define in terms of, as I said earlier only. Okay. If you are giving concentration, that in industry, you do not have to define from normalization. Key, it is in 1NF form or 2NF form. I told you, right? In industry, you have to define like what table design will be best. You don't have to say it is in 3NF or 4NF. You don't have to. Why? Because no one needs whether it's in 3NF or 4NF. Everyone needs whether this query is there, let's say top IT folks in last year, last 10 years or something like that. So such kind of query, does your database design give me without joins or with least amount of join? That's what all people will see. So such kind of design questions we'll see when we see LLD. But my point is, in that way you have to define. Make sense? So that's why I'm just giving an idea what normalization is, what is 3NF and what is 4NF or Bcnf. So in a simplistic example, let's say if I say Bcnf, okay, in a simple table only, I'll try to explain. Okay, let's say you have some data such that you have something like this. You have student, in a simple format only I'm talking about, okay? Student, no roll number, nothing. You have the student's teacher name and the subject. This is your third normalization table, one of the 3NF table. Okay, this is one of your 3NF table. What will be the Bcnf of it? Such a way that if you are defining the table something like this, because for each subject there'll be single table, single teacher. One teacher can have multiple subjects, right? Also, there can be something like this key one subject can be taught by multiple teacher, but this data you are segregating such that simply student and teacher, student to teacher table, that you are segregating such that this relation you can uniquely identify without much redundancy, right? So that is called Bcnf. In a simplistic example, that is also in 3NF, and again this is in 4NF, Bcnf. Furthermore, if it is not much clear, let me take some different example, because I have taken very simple example that previous table is already in 3NF. Now we need something more. So let's consider that after segregating into 3NF, one of the table is something like this: student ID, okay, students, let's say we are not storing address, we are just storing pin code, where student stays, student pin code, okay, and student's department, in which department he is right now studying, okay, and department ID. What is the department ID? Okay, and let's say department, no, this won't be necessary, and let's say timing, something like this in a simplistic way. Timing, what is this department's times or class time, something like that. So for example, let's say your student ID is 123, you are staying into, let's say, 560037, okay. Your student department is, let's say you are in CSE department, department ID is, let's say, DPT1 or DPT1, something like that, and timing of your sessions are, let's say, 9 to 10, one of the session, something like that. Such kind of other rows are also there. You are also part of, let's say this is your address, this is also, you are also part of Mac department for some other course ID also you can think to put it over here, and the Mac department ID is, let's say, department 5, and your class timings are 10 to 10:30 or let's say 11, something like that. The data is there. After some other normalization that you have done on top of other data, this is your final one of the table, 3NF table. Now again further, if you divide it something like this, 1 2 3, student ID 2, just your pin codes, that's it. So unnecessary this data you are resolving. Another table, just department related table, just department related table, which is like CSE. What is the department ID? That's it. And what are the timings of classes? That's it. Okay, there can be multiple rows. Still further you can define based upon the class ID, the department ID, department, and over here, let's say class ID, something like class ID and timing. So that class ID you can define from here. What is the ID of this? So that will be there. And what is the student 1, 2, 3 is mapped to which class ID? So this is in third normal form, that from employee or student, you can find it out all related information, and from department, you can get rest of the information. Right? So the keys, or I would say primary key in some tables are student ID, right? And in this department related information, that if you are putting together, your primary key is department ID and department name, right? So such kind of way, when you're defining, it is Bcnf. Now let's see where or exactly in which way. So just on a prerequisite of some type, let's say when we'll take low level design, we'll take few examples, something like this: design Google Calendar. So in interview or in industry, when you have such kind of requirements, so in industry, what kind of requirement comes? Let's say you are working with some grocery startup, which is like, let's say Zomato, Blinkit, Grofers, Big Basket, any of those. Okay. And previously they were giving all the what you can say orders next day. So every grocery related company was giving next day delivery, right? You put order before 11 p.m. at the night, and next day morning by 7 a.m. you will get the order. This was the initial design that each of the grocery company came up with. Now they are coming up with, let's say, half a day delivery, 15 minutes delivery, 10 minutes delivery. So the project that you will get is that, let's say you are in warehouse management system or order management system. Order management system doesn't change with this, but in warehouse management system, the data will change. What? So here your requirement will be given to you is something like this: we have to adhere to 30-minute delivery. For that, what changes you will have to do into warehouse APIs, what changes you will have to do into warehouse DB, and do that. So this kind of task will be given to principal engineer level, which is like 15 years of experience or 17 years of experience, guys. Okay. So if you're giving interviews for principal engineers, such kind of questions will be asked to you in interview. Say you are a lead engineer. Okay. What he'll do, let's say one of the principal engineer have resolved for API design, one of the principal engineer have resolved for DB. He will design for DB overall, that such kind of design should be there. Your task will be to define which kind of DBs will be for each system. Something like in warehouse storage system, DB design should be different. Orders and which orders have come. Let's say I have ordered 10 items. So that order and items related designs will be segregated. This two could be segregated, right? Whatever the new products are coming up in market and you are storing into warehouse, that would be segregated, right? And some design will be there such that which all items you cannot put together, right? Like something like plastic of atta, right? You cannot put it with the box of blade, razor blades and all that things. Why? Because this, if this is damaged, it can damage this as well. Correct. In a simplistic way. Or let's say phenyl. If phenyl bottle is broken and atta's that is also broken, broken phenyl bottle can damage food items, something like that. So some items you cannot put together, Such kind of design is also there into DB. Now, to adhere to this 30-minute delivery, what changes you'll have to do in this all that a lead engineer will decide. Or generally, the senior software engineer decides, because senior software engineer will be given a task for 2 tables or 3 tables or something like that, or 3 design. And once the design is finalized, they have to adhere to that. So generally in interview also, such kind of questions only will be there based upon your level, that at which level you are coming, similar kind of questions will be given to you. And that way you have to design your tables. Now that is not certainly in 1NF you have to define, 2NF, 3NF, 4NF you have to define, but keeping in mind that what is normalization practice, 3NF to Bcnf sometime is called normal normalization, which generally in industry we use. Sometimes we use 2NF tables as well if it is giving you very high performance in SQL query and little bit average wastage of space, then it's fine. So you have to define like in which way the table structure you will create, or whatever the existings are there, on top of that, which new tables you will create. Got it? So in that way, your tasks will be given to you in company, and in a similar way, your interview questions will be there. As I said, it whatever the level you are, this question, design Google Calendar, will be taken in that way. So if you are 0 to let's say 3 years of experience guy, probably in simple table design, people will consider it. Malab interview will be taken. If you are up to 7 to 10 years of experience, up to, okay, 3 to 10 years of experience, then probably in a high level way, the design will be taken. So if you design this much, then the questions will be on top of this layer. That okay, then what will be the deciding factor for this? What will be the deciding factor for this? What will be the deciding factor for such kind of things? And if you are more than 10 years, these questions won't be coming. Some other type of questions are coming, as I said, key solve for this, right? So in that way, in LLD, when we'll be designing, we'll see at what all level, how you should design. What are the things that you need to consider? Even if at you are at 0 to 3 level, 3 years of experience guys, or up to 10 years of experience guys. Okay. And that is called how a DB design should work. Okay. Now, keeping this thing into consideration, we'll see the next part, which is like NoSQL. What is NoSQL? You all might have heard about NoSQL.
Yes. So if I remember, like NoSQL, like we can store anything. Instead of plain data, we can store.
So some people say NoSQL is as not NoSQL. That means it is not a SQL. Not SQL. Some people say the name is not only SQL. Some people say like that. I don't know what is the name of exactly, or the full form of NoSQL. I don't know about that. But in a simplistic way, in a NoSQL, what you can store. So in NoSQL, there is no definite schema. Like in SQL with 1NF, 2NF, 3NF and all that things, we are defining some schema. When your schema definition may be changing or updating, at that time for those tables, NoSQL is best. At that time. Okay, this is one of the scenario when NoSQL will be best. There are many scenarios when to choose SQL and when to choose NoSQL can be discussed. Okay, but before I start NoSQL, I'll tell you, when YouTube was designed, at that time there were only two tables or two types of, or 2 to 3 types of databases were there: Oracle DB, MySQL, PL SQL, and rest of them. So that means we had only SQL. So when YouTube was designed, YouTube was fully designed and deployed on SQL DB. Okay. And when Netflix came up, at that time, MySQL and everything, NoSQLs were there. So they have used NoSQL and a SQL combination. So my point is, it's not something key, you cannot design something in SQL or you cannot design something in NoSQL. It's not like that. Just the complexity would be different of designing. So there can be some scenario where NoSQL will not at all work. And if you want to work, then your query optimization will increase, or query timing will increase, wastage of space will increase, but you can do that. So you are achieving that, but something you have to accept. So we'll see such kind of scenarios where, but in a simplistic format, if I say what is NoSQL, then NoSQL can be stored something like this in JSON format. Key value pair, I would say. Something like this, let's say ID something, okay? Then student information, like student number, student name, something like this, and rest of the information. Now in one record, you are storing, let's say, address. In same, some another record, you cannot be storing address because you don't have, it's fine if you do not store or adhere to all key value pair. So if you see key value pair, so key value pair are over here, column name and the value, column name, then the value. Now value over here can be complex structure, not just a single value. It can be complex structure in this way as well, JSON format. Got it? So such kind of schema when you are designing, because you need like that in some records there is address, in some record there is no address. So there is no definite schema. In some schema, there are more information associated with that. And in some records, there are no all the schema associated. Let's say over here, the student had KT. You know all about KT, right? Or he has backlog. So instead of 4 years, he has completed his degree in 6 years. So the subjects that he has opted for and the years he has opted for, right? It will be more. Now for some student they have completed in 4 years. So that information will be only for 4 years only, right? So some records or some information or some key value pair, I would say key only, some keys are not there in some records, but there in some records. Example, if with the key only, backlog only, if I store, then something like this, let's say student ID 1, okay, student information, let's say I'm storing into some subject over here, student name, student roll number, address, and all that things I'm storing, okay, and his class information. So what are the subjects and what are the semester 1 he has taken? Semester 1, all the subjects and his passing mark. Semester 2, all the subjects and his passing mark, and so on furthermore. So for this record, up to semester 8, everything is stored. But for some other record, there'll be something like this: student information, class information, and after class information, you will have something like this: KT information or backlog information. So in that you have like semester 2, the guy had KT into 2 subjects, subject 1 maths and subject 1 marks, something like that, right? And in semester 4, so this record is over. In semester 4, So over here only one KT was there. In semester 4, there were 2 such kind of records, because 2 subjects were there on which the guy was failing, right? So this key was present into one record, this record, okay? All this information, similar information you can imagine over here. So this key was present for some record, but this key and their information, kind of information, is not present into some record. So that means your schema is not defined. It can be varying, it can be changing. When you have such kind of requirement, NoSQL is the best way to define your schema. Got it? So far clear? Okay, everyone clear? Abdul?
Yes, yes. So it's latest further. It would be more efficient.
Sorry?
It is latest now after SQL. YouTube.
It's not like, it's not like as it's latest, it's efficient. It's not like that. In some format, in some kind of database design, NoSQL is good. And in some, SQLs are good. So it's not like this is better because it's a new one. I'll tell you example. When you want to define or design transactions, you know about transaction? You can roll back the transaction, right? Cascaded transaction, you might have studied recently. So what are transaction? No doubt when we'll see LLD, at that time I will take it up in more depth, but in a simplistic way, what are the transactions? So let's say from ATM, you are removing money. Okay, so 2 tables or 3 tables are being used. One is student or person's information, that whether this person who is logged in with this card is the same one or not. So person and person's identification, like PIN and all that things. So one table is used to check whether this person is right or not. Then second table is just to see what, value he has in money, how much account money he has. Okay, and third table is transaction table. So when you go and print the passbook, all the transactions are stored, right? So when you withdraw money, it will be reduced from here, like in your total amount, and also the same record will come up over here. Okay, now this whole transaction should do complete in, let's say, 30 seconds or 1 minute. Some example is given. Let's say by chance it is exceeding 1 minute, but identification is completed, amount is reduced, but at the end you cannot create entry into transactional record. So what should have happened? Should you get money or not? No, right? This whole transaction, which was doing transaction in the sense, all the 3 steps which were happening should get rolled back. This is not done, then whatever the money you have reduced, that also should be completed, and whatever the transaction was there, that session also should be invalidated. That's it. Again you have to enter PIN, and again you have to choose amount to withdraw, and then again you'll get money only if all the transactions are completed, right? That means all the steps are completed. So this is called kind of a transaction in a simplistic normal, if I give you definition in a human understandable format, right? That this is called a transaction. That whole series of operations should be completed. They are transaction. And if you want to roll back, SQL allows you to roll back. NoSQL doesn't allow you to roll back. But if you want to design something like that, what you can do? You can do, but for that some more kind of code you have to do. Something like there'll be some code which will check, okay, login done, yes. Money reduced, yes. Money or the transaction has been recorded into third table, yes. Money deposited or money given to the persons from the ATM, yes. Everything done, then perfect. If let's say this is not done, then you have to write down a code to remove this entry. You have to write down a code to remove this entry and then invalidate this session. So such kind of extra code you might have to write such that such kind of transaction you can handle it up from here. Got it? So my point is, it's not like from NoSQL you can do better. It will be more complex, more error prone, but it can be doable. But instead of that, if you would have done with SQL, it will be best. So in a simplistic way, there are some use cases which are best fitted for SQL, which are best fitted for NoSQL. So this thing I'm giving you an assignment. Find it out all these things where SQL is used for and with the example, and where NoSQL can be used. So what you have to do, read about SQL, read about NoSQL use cases. Okay, I don't want format, I don't want, you know, DB queries or anything. I just want you guys to read about those. And let's say some new term came up. As I said, key transaction came up. Probably you don't know. Then read about that. Got it? Let's say atomicity or acid property came up, something new. Now you might remember, okay, I have read somewhere acid properties for SQL.DB in college days. Refresh it. Related to that, what are the properties of NoSQL? Just read about those. Okay, so this is your assignment for this whole week. And going forward with the what you can say DSA will keep on giving you assignments in which one type of code you have done, another type of codes you will have to do. Okay, so this is one of the example that I have given. Few more examples you need to find it out where SQL and NoSQL can be used. One of the famous example that generally I give, okay, is credit card system. So you might have whenever you're going in a mall, you might have seen some person is telling you that, hey, I'm giving you SBI free credit card with this reward point system. Now when you go into website, you'll not see same schema. Ki 1.5x reward scheme for petrol, 1.3x for Amazon, 1.10x or 1.2x reward points for something. So there is some rules that you're defining for some type of credit card, and there are some types of rule for some other type of credit card. Also, there are rules based upon, let's say, how long you are using, what is your credit card ka, maximum limit that you have, what is the maximum tenure that you are using. From based upon that also you are getting some free points and all that things, right? So the point is, all these rules are in different format. Now imagine that this you are storing into SQL, how clumsy it will be. Try to do that, okay, and then try to do that same thing with NoSQL as an assignment and see that which one is more fitting. I'm not talking about normalization or nothing. Just think about which kind of table you will create. We have seen few examples in normalization, right? That which kind of table we'll have to create. So see about those. We'll take such kind of examples more in low level design with efficiency. Over here is just roughly to get an idea. With efficiency, we'll design it into low level design. Right now is this assignment is just to get the picture how NoSQL is used. Okay, clear everyone? Any doubt?
No.
Okay, so with this we have generally seen like in which way the NoSQL can be used, or what is the structure of a NoSQL, what is the structure in which the SQL database can be defined, and then we can move on. So with this, we have seen so far coding introduction, Git introduction, SQL and NoSQL introduction, These all kind of things we have seen. I was about to take operating system introduction, but operating systems algorithm, I'll take it up in algo session, because there'll be some algorithms which are very much similar to operating system algorithms, like first come first served and rest of them. So those algorithm of operating system and how the disk utilization has been used, and those utilizations method can be applied into data structures algorithm. So that kind of things will take it up in algo session. So that's why I'm not right now taking up operating system, because the next chapter itself is data structures and algorithm. So it will be redundant information right now. So that I'm right now not doing. While in algo, we'll see which kind of algorithms were there in operating system, and how in normal life also they are being useful. With interview questions also they are being useful, or in other scenarios are also is being useful. Okay.
You talked about JSON. What is it?
Okay, I talked about JSON. What is JSON? So there are few type of formats. I would say simplistic. If I start explaining you what is JSON, then there are few types of format of data. One is raw data, that let's say text file dot text file you are storing, right? This you know, right? Okay. Now, have you seen .xml, Abdul?
No.
Okay.
No.
Have you seen HTML?
HTML, yes.
Right. HTML
Designing
and
web pages.
exactly. HTML web page you have seen, right? Okay. Then try to see what are the XML format of data. It is very similar. I would say very similar in the sense how a data is stored in XML, that is very similar to HTML. From that, I'll explain you what is JSON. Like in HTML, you have HTML tags, right? Let's say table tag you have, then TDTR you have, right? Remember all these things? Okay. Now, in XML format, the data is defined. Data, because right now we are talking about data. There'll be something like this. Let's say you are writing some information regarding student. Okay. Then student, object, and name, then name of a student, name over, class, in which class he is, and class over. So when you're defining in this kind of a structure, that is called XML structure. In a simplistic example, if I take, now such kind of structure can be much more complex, because you have a list of students. So same kind of a pattern will be repetitive, right, in HTML, right? So such kind of structure, if I write it down multiple, let's say student, then again student, because this is student one information, ABC. Then same kind of structure is for PQR. So something like that I can store, right? More information, related information also I can store, like say class or address. So many things I can store it up in the same format. Now consider that the similar kind of information I'm storing in different format, and that format is something like this. Student, you know about the key value pair. Dictionary, what is dictionary? In Python or C++ or in Java also, dictionary you might have seen. Abdul, I'm asking you.
Yeah, dictionary. I know about dictionary.
Exactly.
There will be
So,
key something. So,
exactly. So
there
because
will
you
be a
asked questions, so
value.
I'm asking you only, right?
Okay.
Right. So in dictionary, what you have data, key value pair, student and student related information. Let's say student name and that information, student roll number and that information, key value pair, right? So that is how in a dictionary you can store it out in Java dictionary. Or if you understand it in terms of hash map, then hash map also you can understand. But hash map is like all unique keys. In dictionary, you can have multiple keys, something like you have student information. Okay, let's say student list, and student list will have all the information like student name, key, and so something like dictionary of a dictionary when you are creating, like complex structure, dictionary of a dictionary. Such kind of structure, if you visualize, then that is called JSON format of storing data. And that is something like this. Let's say student opening array parenthesis, and in that again opening parenthesis, which in which you have directly, you won't have something like key value pair only, it will be directly that. So let's say st, something like that. Okay, then, or let's say id. So st a 1, student id 1, and you have something like this, student roll number something, 1 2 3, then student name something, and complete. Then student id 2, student roll number, and so on, student name, and so on, and this information completed, and so on. You have multiple list of data. So dictionary of a dictionary, or dictionary of a dictionary, you, when you are doing complex structure, when you are storing and visualizing, such kind of thing is called JSON. Okay, now if you see, go out and see few examples on Chrome, well, in Google, you can understand what is, how it is related with XML, and from XML, because you know HTML, very much similar to that is XML, how XML related data is stored over here or understandable over here. Okay, so with this we are stopping our session today.